Hello everyone, welcome and thank you for joining us today. My name is Konstantin Bulatov. I'm the Chief Technology Officer at OCR Studio, and I'm welcoming you again to our today's webinar entitled WebAssembly-powered browser OCR, the future of document scanning. So we will be talking about web technologies. Over the past 20-25 years, the web has been repeatedly reinterpreted through conceptual versions, you might know. These aren't standards, these aren't something which specified. They're just, frameworks that help describe how the role of the web has changed over time. You remember Web 1.0, it was static web pages. Web 2.0 was about social interaction, user-defined content. Web 3.0, which is about decentralization, is the web we are using today. And Web 4.0 is emerging right now as an intelligent environment where AI and connected devices anticipate user needs. Now, Web 5.0 is interpreted in a different way, either as an emotional web with machines understanding human feelings, or, I believe more sensibly, as a fully decentralized web where users control their identity and users control their data. Now, whether or not these labels become universally accepted and adopted, they reflect a trend in the global discourse. Each shift between the versions of the web increase expectations for what the web should be able to do. Businesses want richer interactions, real-time decision-making, seamless user onboarding, frictionless identity verification. And to meet these expectations, the technological foundation of the web has to evolve, as well as the expectations. Now, this brings us to a key point, one that is still not widely discussed. There is actually a major technological breakthrough in the modern web stack that makes this shift possible, and it makes it possible to do things that were previously extremely hard and in some cases practically impossible. Today we can run advanced computationally intensive computer vision, including full-fledged document analysis and document scanning directly in the browser page without having to transmit images to an external processing server. In this session, we will explore how WebAssembly makes this possible and how it reshapes identity verification, onboarding, payments, and other everyday digital workflows. Now, before we begin, a few words about us, about OCR Studio. OCR Studio is a company that develops high-performance document recognition technologies. OCR for IDs, for passports, for driving licenses, credit or debit cards, barcodes and QR code recognition systems, and system for scanning other objects such as VIN numbers, license plates, utility meters, and the like. All our recognition engines are built in-house, allowing us full control over the code base, over performance, over accuracy, and over security, and they are always built in such a way that all image processing stays local on the user's device without any data transmission. So when you use our product, the images that you process do not come to us. They are processed immediately on the device where the capturing happens. These technologies are used today worldwide by organizations that rely on fast and reliable document capture. These are primarily financial institutions, so banks and fintech companies, telecom operators, logistics and delivery services, We have some retail and e-commerce platforms as our clients and some public service systems as well. Organizations today rely a lot on camera-based scanning, ID verification for KYC processes and onboarding, credit card capture for payments, QR and barcode scanning for logistics and retail, and structured text extraction such as forms and invoice processing, etc. These flows are now expected to work instantly with minimal friction and consistently across different channels of business-to-user interaction. People, users, don't want to use a separate app just to scan a document. The document scanning automatization should be integrated into the business channel. So businesses work seamlessly across web, desktop, mobile apps, progressive web apps, messenger mini apps, and thus they want the same behavior everywhere, ideally without duplicating development effort and duplicating development costs across the platforms, but certainly without compromising features, including the feature we are most interested about, the document scanning. We know this very well. We talked about it on one of our previous webinars on omnichannel ID capture. And exactly for this reason, we develop our scanning software, our scanning engines for every platform, web, mobile, server. Anywhere the client, the holder of the document, might want to scan their ID. Another part of the story is privacy and data locality, data security. Modern privacy and data protection frameworks, the best known is the European GDPR. There are some youth protection regulations, sector-specific rules for handling identity documents and private data. They increasingly emphasize data localization, for example, within the border of a country, purpose limitation, and strict control over sensitive images, particularly images of sensitive documents, for example, or images of faces or other biometric images. In practice, organizations are expected to avoid collecting or transmitting such data, unless absolutely necessary, and to reduce the exposure of this kind of sensitive images which can be intercepted, which can be stored, leaked, and used improperly. The traditional web architecture assumes that the browser or the front end handles the interface with the user and handles the data collection from the user, for example, using user-uploaded image files or using the web camera for real-time capture. But the heavy processing, like OCR, like document analysis, like computer vision, happens on a remote backend. This means that images must be uploaded. They have to be stored temporarily, transferred, and processed under a set of compliance controls. And these compliance controls vary from region to region, from country to country, from provider to provider. Our approach is different. Instead of adapting to every jurisdictional rule about server location, data transfer, and data storage, we avoid these questions entirely by performing document scanning directly in the browser. So when processing happens on device, the images stay with the user. They are never transmitted over the network, simply because there is no need for us. With our technologies, there is no need to transmit these images to the server. And for many years, this was not technically feasible. Browsers did not provide the performance or execution model required to run production-grade OCR or computer vision for identity documents and any kind of production-grade image processing pipelines. WebAssembly changed that, not magically, but by providing the developers the necessary tools and necessary low-level building blocks to adapt their technologies to be able to execute it on the browser page. And now we can create web-based document scanning products which have the same level of privacy and on-device capabilities as native software, as native SDKs. And this is the topic of today's webinar. Before we go deeper into the technology, let me show you how it could look in practice, just as a very, very small and easy demo. So imagine that I'm opening, this is a demo page. By the way, you can test it yourself. You can just access demo.ocrstudio.ai. Let us select the machine-readable zone document, which you can find in any kind of passports. It will open a camera. I can show it to the camera and click on capture. And instead of sending these images, as you can see, it already captured all the data and extracted both the photo and the text information. And the crucial point is that this solution, this SDK, instead of realizing a traditional client-server paradigm, instead of sending the captured images to a server for processing, it downloaded from the server a WebAssembly module which allows the browser to perform all these computations required to do the OCR of the document directly in the browser. No images has been sent off. And this is the kind of technologies we'll be talking about today. Let us talk about historical context. For many years, JavaScript was the only language browsers could execute. It's great for UI, great for application logic, not ideal for heavy mathematical operations. As applications grew more demanding, especially in cryptography, especially in handling cryptocurrencies, computer-aided design, gaming, and so on, developers needed something more powerful. Around 2010, work on Emscripten began. It was an LLVM, the low-level virtual machine-based toolchain that could compile C and C++ code into JavaScript. So Emscripten didn't make JavaScript more powerful in the usual sense. It didn't remove it from the equation. The output was still JavaScript. But it was JavaScript used as a low-level execution language, not as a language a human would write the code. This was the key idea. So native code, for example, computer vision system, computer vision code, could be mechanically compiled into something the browser could run, even if that something was still technically, it was a JavaScript code, just software-generated JavaScript code. We actually tried this ourselves many years ago. We ported early versions of our real-time video-based computer vision pipelines into JavaScript using Emscripten. It worked technically, but the performance was nowhere near usable for real-time OCR or video analysis. And processing each frame captured from the camera required enormous resources, multiple seconds for each frame. And the generated JavaScript bundle also was more than hundreds of megabytes. So again, too large and too slow to be any kind of practical. A few years later, in 2013, Mozilla introduced ASM.js. It was a carefully restricted subset of the language, so highly optimizable subset of JavaScript. It demonstrated that JavaScript engines could be tuned to run low-level compiler-generated code significantly faster. Emscripten and ASM.js complemented each other. Emscripten could emit ASM.js, and browsers could then optimize it more aggressively than ordinary JavaScript. These efforts showed the path forward, but they were still constrained by the fact that everything ultimately ran as JavaScript. The real turning point came when browser vendors and standard bodies like W3C began defining a new binary execution format for the web. Around 2015, this collaboration crystallized into WebAssembly, a compact, sandboxed, low-level intermediate compilation target designed for predictable high-performance execution. And by 2017, WebAssembly was supported in all major browsers. Well, at least technically supported. Not all features were supported, but it was technically supported. WebAssembly didn't replace the previous model, it just extended it. The same Emscripten toolchain could now compile low-level C++ code not into JavaScript, but into this WebAssembly, into this intermediate language. It's like a binary blob of compiled data. And then browsers, they didn't, and still, they don't interpret this format directly. They translate it into a native execution module. Basically, they translate it to a module native for the platform the browser itself runs. And then they can execute it inside a sandbox. So the core idea stayed the same. Your code is compiled into a low-level target, in this case WebAssembly. The target is embedded inside your web page, which is, again, it's JavaScript, but it interacts with this WebAssembly low-level module, and the browser executes it efficiently and safely. The difference is that WebAssembly finally made this pipeline fast enough for production-grade compute workloads, including OCR, including computer vision. So if, like us, you own your own code, you don't rely on any opaque third-party dependencies, you can compile your software into WebAssembly and run it in the web page with almost native speed. And this is what made production-grade document scanning and OCR possible on the web. So what our WebAssembly engines actually do today. So over the last couple of years, we've brought the functionality of all our native document scanning SDKs, document scanning systems, into the browser. Same algorithms, same accuracy, same security model, but now in your web page. These capabilities form a complete, ready-to-use product stack. First, high-precision ID document scanning. Identity documents remain the backbone of onboarding, KYC processes, access verification worldwide. Our ID recognition engine runs entirely in the browser page. It can support passports, national IDs, driving licenses, residence permits, many other document types, and more than 100 languages. The system extracts structured fields, validates internal consistencies, works both with laptop webcams, mobile device cameras, and so on, directly inside the same browser page. It will work both on a laptop using a webcam or on a mobile device using the mobile device camera. Users can simply show the document to the camera, and all data from the identity documents are instantly recognized and extracted and added to the form fields of the same web page. This eliminates manual data entry, streamlines your KYC processes across all platforms, and makes the customer journey shorter. Second, bank cards, credit or debit card scanning for payments and fintech flows. Our WebAssembly scanning engine also performs credit and debit cards recognition entirely on the client side. Again, reading card number, expiry date, cash holder name, all the data from the bank card directly using the webcam or using a mobile camera. So this technology is particularly transformative for fintechs or neobanks seeking to manage user wallets, automatize payment acquiring procedures without sacrificing security, or cross-device compatibility or omnichannel compatibility. Now, barcodes, QR code scanning. Of course, OCR Studio includes a high-performance in-house built barcode and QR code scanner, which we also compile to WebAssembly, and thus it is also possible to use it on the web. This enables instant scanning for logistics applications, for delivery apps, for retail verification flows, self-checkout processes, etc. Again, entirely in the browser. And selfie ID verification, face matching. This technology verifies the user's face to confirm the presence of a live person and compares it against the reference image extracted from the photo of the ID card or the other ID document like a passport, without transferring any of the images to third-party servers or even to your server. The solution is designed to prevent spoofing attacks during the onboarding process in web environments and for implementing, for example, age verification scenarios and similar processes. Now, this is our ready-to-use product stack. Beyond ready-made products, we can bring any of our recognition modules into WebAssembly, because we also do reference numbers, tax IDs, shipment, labels, general structured text, like loyalty cards, access badges, etc., other industry-specific recognition tasks. If you need to scan the specific document, we of course can do it using and ship it as a server-side SDK, as a mobile native SDK, and also as a web SDK, which can be used directly inside your browser page. Since we own and control our image analysis and document recognition pipeline, from low-level math to higher-level pipelines and concepts, we can compile and adapt these components for web whenever required and create custom business solutions as well. So, across all these categories, the principle stays the same. Capture runs locally, webcam, device camera, uploaded image. The images do not leave the client side for processing, or at least they don't have to leave the client side for processing. Recognition runs fully on device, inside the WebAssembly module. Latency stays extremely low, again, because the processing is local, you don't have to send the image data anywhere. And one engine works everywhere. Because it's a web-based system, desktop platform works, mobile platform works, as well as other web-based channels like PWAs, like progressive web apps, and like Messenger mini apps. I will be talking about it a little bit later. So let me show you how the same page works. Let me again share my screen. Now this is the demo from before. Let me now try. This is a sample of an ID card of Qatar. It has numeric fields in English and fields in Arabic. So I point it to the camera, I click on capture, and it performs a real-time video-based scanning, because we actually capture multiple frames in order to increase the reliability of the scanner. And again, it extracts the rectified image of the whole page. It extracts the photo for face comparison after that, and it extracts all the text fields which it sees. And now let's do the same thing on the mobile device. Again, so I'm opening the same page, but now using a mobile browser. And by default, it uses the rear camera of the mobile device because it has higher resolution. And again, on the mobile device, using the same page, you can do scanning of the same document. Again, extract all the data fields. Again, extract all the graphical fields as well. So that's it. How to integrate this, how to have this product inside your infrastructure. So when integrating our Web SDK, there are several important differences compared to mobile native SDK and for server SDK. Now, first of all, the configuration, so the file which defines what kind of documents are supported, what kind of objects you can scan, it's typically embedded directly inside the WebAssembly binary. So the browser receives a single compact module which has everything it needs to scan. Delivery usually includes multiple WebAssembly modules because different browsers still support different feature sets. So we ship a package containing multiple WebAssembly builds in the same configuration, and there is a backend component which automatically selects the correct module for each client. So when a client accesses it from Safari or a client accesses it from Chrome browser, the backend automatically understands which module to ship to the front end in order to maximize the performance for this specific browser. A important thing is that a server-side authorization component is always required for all WebAssembly SDK builds because the scanning module is ultimately running inside the browser page of the user. So that means that user can, not theoretically, very, very practically, simply get this module and then use it illicitly for scanning itself. So in order to do the protection of this component, there is an authorization process which does not involve sending the data because it actually happens before the recognition. And it is happening using our supplied authorization SDK. Every scanning session, before it receives any images, must be signed to unlock the functionality of recognition. And in order to sign these requests for activation, we supply a specific authorization SDK, which can be deployed on the same server as you use for the backend for hosting the web page, or it can be a separate endpoint, doesn't matter. The main thing is that you also control the scanning process, the signing process, which is required before each scanning session takes place. Now, we also supply a JavaScript wrapper to manage the lifecycle of the WebAssembly engine, and we provide a sample application, sample front-end web page, which shows quickly how to integrate it into your web interface. Based on this ready-to-use code, you can get this functionality up and running in your website within hours, maybe. So this architecture enables fast loading, secure execution, and as WebAssembly, it enables predictable performance across all environments. So let me show you how our SDK delivery looks like. So as I said, there is two components, the WebAssembly module itself and the activation tool. So firstly, let us launch the activation tool. Again, it's an SDK which you can integrate inside your backend system in order to be able to sign the activation messages. And also it is applied with a very simple sample server written in Java, which can be used immediately in order to see how it works and in order to test the WebAssembly SDK. So the first thing I have to do is go to the activation tool sample and launch the activation server. There is a setup script. The operating system will ask me if I trust this software because it's external binary. Click on OK, allow it to be run. Okay, the server started. Now I have to, for the first time, open the URL. It tells me in order for the server to be initialized. So right now the server is initialization, and now it tells me that activation server works. Now this server is already running locally on my MacBook, and now it can sign the authorization requests. So now Let's open the actual SDK package. So when you receive a WebAssembly SDK package for a specific configuration, you receive the archives like this. It contains a bin folder which actually hosts the WebAssembly modules. In this case, the configuration is for bank cards, for credit and debit card scanning. There is a doc folder with various documentation of our system. There is an index.html. This is the sample application, which is ready to be run. The app.js is its code. And the worker.js, it's an intermediary between the app.js, between the client-side code and the WebAssembly module. And there is also OCR Studio SDK Func.js, which is an auxiliary functions. So this sample application can be readily run as a node app. So again, we simply go to this directory, run npx serve. It launches the application, and now it tells us the URL. We can open. You can see this is the sample application. It asks the permission for camera. Again, we allow it. And I can point the bank card, start capture, and it reads all the information. So it's easy like that. Today, the browser is no longer the only entry point for digital services, even if we are talking about web technologies. Many user interactions now happens in lightweight environments that feel native to the user, even though they're not traditional mobile or desktop applications. Progressive web applications, PWAs, and messenger mini apps have become a natural part of this specific landscape, allowing businesses to deliver full featured user flows without building and maintaining separate native apps for each platform where the user might want to access their services. Messenger mini apps illustrate this shift particularly well. Companies increasingly interact with users directly inside messaging platforms, such as Telegram, WhatsApp, WeChat, Discord, and others like that, simply because that is where communication already takes place. And to support more complex scenarios, messengers provide bots and mini apps with interactive features that go far beyond simple text-based chat. They can be used for identity checks, for example, for age verification, in order to access some specific content. By the way, we have a dedicated webinar focused entirely on age verification. You can access it through a website. Technically, these environments, PWAs, mini apps, are still based on WebStack. As a result, they support WebAssembly because ultimately they open some web page in some web engine, and so they actually support WebAssembly. And that means that our WebAssembly-based products work there as well, with the same performance, same privacy model, same UX as on a regular website, on a regular web page. The same recognition logic can be reused across multiple websites, across multiple PWAs and messenger mini apps without rebuilding the solution for each channel of user interaction. So this makes it possible to extend document scanning beyond your regular native apps and beyond your classic web pages and keep a consistent experience, still privacy preserving, everywhere the user wants to interact with the service. So as a quick demo, let me show you our demo Telegram bot. So this is a demonstration for age verification. This is a Telegram mini app, and you can see the Telegram mini app actually opens an internal browser. So I'm scanning the UK driving license in order to make sure that I have a correct age. I have to look into the camera to do a face comparison. And age is not verified because this is not my face. Face similarity is only 2%, but it extracted all the fields, including the date of birth. And if the face had been similar, I would pass the check. Across the industries, we see a shift, or at least an intention to shift, towards architectures often described with a set of Web 5.0 principles. A web that is user-controlled, privacy-first, secure by default, and free from unnecessary personal data exposure. And this aligns very well with what we at OCR Studio believe should happen with the web, and not only with the web. And intelligent document capture, which is our specialty, should follow the same trajectory. WebAssembly can be the foundation that makes it possible. We believe that the future of document scanning is client-side, instant, privacy-preserving, and omnichannel in terms of user-to-business interaction. And this future is not theoretical. It already exists today. OCR Studio delivers an out-of-the-box WebAssembly OCR engine that runs 100% inside the browser page, preserves user privacy by not sending the private data anywhere, and provides high-accuracy document recognition, integrates seamlessly with existing web pages, existing PWAs, mini-app flows, etc., and can be deployed within hours, not weeks or months. With WebAssembly, organizations no longer have to choose between strong security, great UX, or omnichannel reach. They can have all three, provided by a single scanning engine that works everywhere. This is the direction the industry is heading, and we at OCR Studio are already here. That's it. Thank you very much. Now, I have said everything I wanted to say. Let's now go to Q&A. So if you have any questions, have you already raised any kind of questions during the webinar? Not yet. So if you have any questions, please raise your hand, or you can write it into the chat. Oh, we already have a question. How does your licensing model work for WebAssembly OCR? Yeah, so our licensing model for actually all of our SDK types and all of our products, so server-side SDK, mobile native SDK, and WebAssembly SDK is the same. The general model is per scan licensing. Even though it is an offline system, even though the data never comes to us and we can never control the client infrastructure, we still approach it as a per scan because it's easy to calculate in terms of all of our clients. So you license a prepaid package worth some specific, let's say, 1 million scans a year, and then every quarter you report us back in a written and signed official form how many scans have you consumed. So this works across all of the channels. For example, you can use our server SDK and our mobile SDK and our web SDK, and you can simply calculate the total number of scans you performed using all of our versions of the product. And then we base our accounting and invoicing based on the number of scans you consumed. Thank you for your question. Any more? How do you count the scans? Yeah, so we don't, because again, we cannot have access to your infrastructure. That wouldn't be privacy preserving. So in the general model, default model, you have to count the scans yourself. When we sign the license agreement, we specify the procedure where you perform the scanning yourself, but you submit an official signed and stamped reports of how many scans you consume in written form, and then we base our balance accounting on this kind of user reports. So this is a general topic, general theme, because we cannot we cannot count your own scans. It also allows us to constitute and state in written form in the license agreement what exactly constitutes a scan. Because in some applications, the scanning happens in the public part of the application. For example, let's say an airline check-in, and customer requested us, so okay, the users can scan the passport and then we can use this information inside of business process, or they can simply, scan the wall or send pictures of their cats or whatever. So we don't want to pay for that, and we agreed with that. So we don't want to count the scans which were completely unused because it did not contain any kind of documents. So because we have a user-defined scans, we sometimes also specifically write what constitutes a scan in the specific case. There is an option where the scanning, the counting happens on our side. I talked about the authorization SDK. We have our own authorization server, which is optional to use. So default mode is you have the authorization SDK and completely cut off from our infrastructure. If you don't want to use it, you can use our authorization server, but that means that before you do the scanning, you must send the authorization request to our server. And we can count the number of requests you did, and thus we can maintain a balance without you having to count the scans. But that means also that we cannot count the number of successful scans. We can only count the number of calls you made, because we don't get any data. We don't know whether you used the scan or not. We didn't see the document. So again, the default mode is you count the scans yourself and then report us back within a predefined, pre-specified procedure. We have another question. Are there any browser limitations or differences when running WebAssembly OCR? Well, I mentioned it a little bit. So the WebAssembly currently is very dynamically evolving technology for the web. It has many different features. It has multi-threading. I think the model of multi-threading recently changed in the latest version of MScript and compiler. It has single instruction, multiple data instructions, and all of these different optimization base. Basically, they are used for increasing the execution speed. All these different features are supported by some versions of the browsers, not supported by others. That's why we monitor all the major browsers and major web engines, how they interact with the WebAssembly, and we create like a excessively large set of modules which cover all the browsers, and you don't have to think about what WebAssembly features will be enabled for the browser, for this browser or for this browser. So we already ship the WebAssembly modules with the backend component, which automatically choose what WebAssembly module can be loaded into the specific browser. Yeah, so there are differences, but you can be sure that most of the modern browsers already support WebAssembly, and yeah, because we already have not browser-restricted customers who test and have production applications running our software, and we regularly test different types of browsers and new versions of browsers for the potential problems with WebAssembly SDK and update our system regularly in order to support these new versions of the browsers. Yeah, okay, I think we can finish with the questions here. If you have any other questions left after the webinar, or you'd like to explore WebAssembly OCR and our products and integrate it into your systems, into your products, and automate your KYC, your onboarding process, your age verification, or other document scanning procedures, feel free to contact us via email. You can leave a request at our website, and also the demo page which I opened during this webinar. It's live. You can test it yourself. It's demo.ocrstudio.ai. You can test it using your browser with a web camera. You can test it using your mobile and using the mobile camera as well. You can also meet us in person at upcoming industry events, but now already next year in 2026. So that would be MWC Barcelona, Mobile World Congress Global version in Barcelona in the beginning of March. GITEX Asia in the beginning of April. It will be held in Singapore. And AI Everything Global Edition. It will be held in May in Abu Dhabi, and near the same dates, Seamless Middle East exhibition, which will be held in Dubai, also in May. We will be showcasing all our latest WebAssembly-based technologies on these exhibitions and on these events, and we'll be happy to discuss your specific use cases, your specific projects, your specific needs on these events offline. So thank you very much for coming. Thank you very much for your attention, and let's stay in touch. See you.